Hello everyone. Let's see the calculation of law of polygon of forces. So after doing the experiment of polygon of forces on the universal table, we got some observations like forces in grams and angles in theta. Here are the some one example, that is we get the 5 number of forces simultaneously: 150 gram, 200 gram, 175 gram, 150 gram and 175 gram. According to that angles, theta 1 is 0 degree, theta 2 is 74 degree, theta 3 is 115 degree, theta 4 is 218 degree and theta 5 is 291 degree. So let's draw a first of all space diagram according to that forces and the angle. As we know that the quadrants, that is x plus x axis minus x axis plus y axis and minus y axis. So let's draw a space diagram. Okay, now here I am drawing the plus y axis and plus x axis. As I am writing the forces in grams and angles in theta, so first one is first force is F1 given in 150 gram. According to the angle theta 1 is a 90 degree. For that quadrant system, we know that here is assumed as a 0 degree or 360 degree. Here it is a 90 degree, here it is a 180 degree and here it is a 270 degree. So according to the observation, F1 is a 150 gram according to the angle of a 0 degree. So we can show it like a F1 150 gram on the 0 degree. The second force is 200 gram having an angle 74 degree with the positive x axis. So the 74 degree lies in 90 degree and between the 0 degree and 90 degree. So draw a F2 force on the first quadrant by taking the measurements with the bisectors. Draw a F2 force 200 gram having an angle with the x axis is a 74 degree. Same like that, we can draw all the forces according to this angle with the x axis. So here it is right as a x axis and here it is a y axis. Let's draw all the forces according to the angles. Let's see, here I am drawing all the forces according to the degrees. So first F1 force lies on the x axis, F2 force which is 200 grams having an angle theta 2 74 degree which is lies in a first quadrant, F3 which is 175 gram, theta 3 is 115 gram which is lies in a third quadrant, F4 150 gram, theta 4 is 218 degree, so F4 is lies in a fourth quadrant, and F5 is 175 gram having an angle 291 degree which is lies in a fourth quadrant. So do not forget to write down the angles which is showing in figure. So F2 is having 74 degree, F3 is having 115 degree, F4 is having 218 degree with this x-axis, and F5 is 291 degree with the plus x-axis. After doing this space diagram, we can draw a vector diagram or force diagram by using this. So we require the scale for drawing the force diagram. So let's calculate the scale or define the scale. Just see all the forces which is in a absolute number, that is 150, 200, 175 gram, 150 gram and 175 gram. Let's assume the scale for 1 centimeter let's assume, you can assume as a 25 gram, 50 gram, 100 gram. So 50 gram is suitable for all the forces. So I am taking as a scale 1 centimeter is equals to 50 gram. So calculate for first force having a 150 gram. According to the scale, the force will goes to the 3 centimeter. So let's see step by step calculation for the first forces. So we know that 1 centimeter is equals to 50 gram. We have to calculate the length of first force, that is 150 gram. So right here the 150 gram. We don't know the same length for the drawing force diagram. So after doing this, just do a cross multiplication, that is 150 into 1 is equals to 50 into x. So we can calculate the x by dividing a 150 by 50. We got the x is equals to 3 centimeter. So we are going to this 3 centimeter for drawing a space diagram. Before that, we have to show a Bose notation. So first, do not forget to show a Bose notation. What is the meaning of Bose notation? We know that, or for drawing a space diagram, we know that the all forces which is in a according to a some distance from one another. So how can we represent the F1 force in a force diagram? So Bose notation is nothing but to donate or denote the spaces according to a number or letters, that we can represent the force in a numbers or letters. Same like if this force F1 is lies on the x-axis, this space is remaining, this space is remaining. Bose notation is nothing but to donate a spaces like a letters. So write here a and write here a b. These are the Bose notation. So we can say that F1 force is lies between the space A and the B. So we can write the force AB having a 150 gram with the 0 degree. So the same like we donate all the forces. So this is A space, this is B space, this is C, this is D. We have to show the Bose notation between the forces spaces, not on the quadrant spaces. So we have to show Bose notation on the forces. So here it is A, B, C, D, and here it is a E notation. By using this, we can draw a force diagram. Let's draw a force diagram. So for drawing a force diagram, we know that so write here all the forces in grams. So write here on grams. So we have to convert by scale in the centimeter. We calculate first force, that is 150 gram force according to the scale is 1 centimeter is equals to 50 gram. So here it is a 3 centimeter. So for 200 gram it's 4 centimeter and 175 gram is 3.5 centimeter.